Good day. I'm Dr. Farala Pia of the Department of Mathematics, Emmanuel Ayinde, University of Education, Oyo. Today we want to learn something on the Moivre theorem. This is a very important theorem in complex analysis, the Moivre theorem. And the Moivre theorem assists us in solving some problems in complex analysis. So what does the Moivre theorem says? That theorem says that let z equals r cos theta plus I sin theta. Then for any natural number n, z raised to power n is equal to r into cos theta plus I sin theta, everything raised to power n, is equal to r raised to power n into cos n theta plus I sin n theta. So in this theorem, we see that when z is expressed in polar form, then z raised to power n, when it is simplified, will be equal to r raised to power n cos the argument of z multiplied by n plus I sin argument of z multiplied by n, that is theta. So that is what we have there. Let me now try to solve this problem. Prove the Moivre theorem for us. What does that theorem says? N theta raised to power, is equal to that. So let's try to look at the proof. And we want to use mathematical induction to show that z raised to power n, which is r cos theta plus I sin theta, all raised to power n, equals r raised to power n into cos n theta plus I sin n theta. Now, we can do away with our z. So we now have this one equals this. So we have the left hand side and the right hand side. So using the principle of mathematical induction, you have let n equals 1. Then our left hand side equals r into cos theta plus I sin theta, everything raised to power minus 1. And this is equal to r cos theta plus I sin theta. Now, the right hand side equals r raised to power n. So n is 1, so we have our 1. Then cos n is 1, so that is 1 multiplied by theta. Okay. Then plus I sin 1 multiplied by theta. So we have that. And when you simplify this, you have r into cos theta plus I sin theta. So we discovered that the left hand side and the right hand side, they are the right hand side, they are equal. Therefore, we conclude that the proposition or theorem is true for n is equal to 1. So the next step is to assume that it is true for n is equal to k. So assuming n is equal to k, we have r cos theta plus I sin theta, everything raised to power k, is equal to rk raised to power k cos k theta plus I sin k theta. So we assume that this one is true. So consider r cos theta plus I sin theta, everything raised to power k plus 1. So if you are able to show that this one is also true, then we conclude that the assertion is true for all positive values of n. So this one is equal to r, you have your, this one will now be r equals, this one is equal to r into cos theta plus I sin theta all raised to power k, then multiplied by r into cos theta plus I sin theta. That is using principle of indices. If you have a raised to power m plus 1 will be equal to a raised to power m multiplied by a. So this is our am and this is a. So we'll now try to simplify this. This one is equal to, this part here is the same thing as this. So this part will be equal to r raised to power k into cos k theta plus I sin k theta, then multiplied by r into cos theta plus I sin theta. Okay. Now if you look at this one, our r and rk here will be r into k plus 1, then into cos k theta plus I sin k theta into cos theta plus I sin theta. So that's what you have. And this will be r raised to power k plus 1 into, let's open the bracket. You have cos k theta multiplied by cos theta, then this one multiplied by this is this one multiplied by this will be plus I cos k theta sin theta, then plus I sin k theta cos theta plus I squared sin k theta into sin theta. So that is what we have. And this is the same thing as r raised to power k plus 1 into, now we have this, the first term here will be cos k theta cos theta, then this I squared will be this I squared, I is root of minus 1, so I squared will be equal to minus 1. So this becomes negative. So we now have cos k theta cos theta minus sin k theta sin theta. Then plus, you factor out I from your cos k theta sin theta plus sin k theta cos theta. So this will be equal to r raised to power k plus 1 into cos k theta cos theta minus sin k theta sin theta is nothing but cos k theta plus theta from simple addition formulae in trigonometry plus I into sin k theta plus theta. So that is from simple addition formula in trigonometry. So cos k theta sin theta plus sin k theta cos theta is nothing but sin k theta plus theta. So if you expand this, you get this. If you expand this, you get this one. So let's factor our theta here. We have our k plus 1 into cos k plus 1 into theta plus I sin k plus 1 into theta. So this is true. This is true for n equals k plus 1, and so it is true for all integer values of n. So that is the end of the proof of the math theorem. So this the math theorem is a very important theorem for us. Another shortened form of it is that cos theta plus I sin theta, everything raised to power n, is cos n theta plus I sin n theta. So this one is very, very important to us. This particular theorem. So let's try to look at one or two examples on the application of the math theorem. So that will be the next thing that we are going to do in the next class. Thank you.